Welcome to this video on the introduction of matrices and how they tie into a system of equations. So, if you have not done so already, you can take a look at your note sheet because the note sheet has some information that you can fill in terms of a chart. Now, the whole purpose of matrices is to help make your life a little bit easier when you are trying to solve a system of equations, whether it be a 2 by 2, which means two variables, two equations, a 3 by 3, three equations, or three variables, or even something bigger than that. All right, so I wanted to give you a little bit of an introduction by giving you a table that talks about eye color. So I have filled in different values for the amount of males that have brown eyes and females that have blue eyes and so on and so on. And we're going to make this into a matrix. So a matrix, when we actually write it, notice it says we want to turn it into a matrix, and the definition says a rectangular array of numbers written with brackets. So our matrix in this case is going to have brackets, and there's going to be numbers in each spot. You'll notice that the matrix that we have from the chart above is only going to deal with the numbers that we have. It is not going to include any of the labels that we essentially have as well. Right? We would be able to identify that in other ways, as you'll see moving forward. Okay? But notice how there are 6 total numbers. So that means you need 6 total spots inside of your matrix. And each one of these spots has a particular meaning to it. So we know that in this case, each of these areas have rows going from side to side, and then these are going to have columns going up and down. So when we look at the dimension or the order of it, the rows are always the very first things that we have. So notice how this spot would be row 1. Okay, we would have row 1 in that spot, and we would have row 1 there. Each of those first 3 numbers will deal with row number 1. And if we're then trying to follow it by the number of columns, well, we would have this very first spot would be row 1, column 1. It's the first spot in each. The middle spot on the top would still be row 1, but it would be the second column that we actually have. It's spot 1, 2, or spot 12. And then if we go all the way through and have first row, third column would be spot 13. Now we would do that same thing, and just to identify the actual location inside of the matrix that we're dealing with. So if we look at the bottom row, we would have row 2, column 1 in the very first spot. We would have row 2, column 2 for the middle spot, and we would have row 2, column 3 over there. Now that is just identifying the spot in each one of the matrices. We just put numbers in now, because we know that there are 13 males that have brown eyes. That number is the actual number we're putting in for the matrix. And we keep going. We have our 20 be in the last spot, and the other spot for the males would be 5. We can continue going through the second level, and now we have, well, it just so happens that that number is a 21 as well. Okay, we have 11 in that spot, and then last but not least, 6. So when we ultimately put things into our calculator, we're going to notice that we're going to use the numbers that I have here in green and not the numbers that I have here in blue. The blue numbers are going to help us identify different parts of our matrix. So now as we're going through, the very last thing is, well, what is the order of this? How many rows do you have? Well, it's kind of nice that we labeled everything out because we have 2 rows, and then how many columns? We have 3. The order of this matrix is actually a 2 by 3. And so you can see we're going to use some of these pieces of information moving forward now. Right? So I have a different set of table, I would say, that has driving distances in miles from Wisconsin cities to cities outside Wisconsin. So if we're trying to write this as a matrix, our goal is to use all of these numbers only and put into a matrix. Now I kind of like to branch off and separate it from all the labels that we have. And now in this spot, I'm going to make my big brackets here. And I know that the very first spot is going to have my 148, my 270, my 1,278, my 1,711. So now you'll notice that we would have a key, or we could have a key off to the side with some of the labels of what the rows stand for, what the columns stand for. But we don't need to put that in here, and we also don't need to put the spot 1, 1, the spot 1, 2 in every single matrix. But if I asked you to identify what spot 13 is, you should be able to know that means row 1, column 3, and the number I'm referring to in that case will be your 1,278. So rewriting the matrix is really simple, because all we have to do is rewrite them in the order that you see them in your table. And as we go through, just making sure not to make a simple, easy mistake when you're copying down numbers. That's a very easy thing to do, especially ultimately when you see we put these into our calculators here. Okay? But now, with this very last one, with all the information to Claire, the next part we're going to have to figure out is what the actual order is of this particular matrix. Notice how it's always rows. Rows are off to the side. Okay, they go side to side. So how many rows do we have? You notice that we have 4 rows. How many columns do you have? You'll notice that there's 1, 2, 3, 4 columns as you're going up and down. So the order of this matrix is actually a 4 by 4 matrix. Right? That's going to be an important piece of information as we go through. And now this is a very basic matrix. This is as basic a matrix as you can possibly have. There are different types of matrices, the plural form, that we actually have. The first one is something called an augmented matrix. So you can fill this piece of information in. It says it's a matrix used to represent a system of equations, and it includes a vertical line to separate a column of numbers. This is the most important part that you will see about the augmented matrix, and it's going to make your life super easy. Okay? So what I'm going to do here is I'm going to actually make each one of these into a augmented matrix. So before we do that, though, we do have to make sure that the right order is actually listed for every single one of the equations that we have. And you'll notice that the first equation only has an x and a y, but then the other two equations both have a z. So what may not be a bad idea is to rewrite these and make sure that you know, like in that first equation, there's a 0 z there. Otherwise, our matrix might look a little bit funky. The very next one, the second equation, make sure you have a 0x in that case. And then you can rewrite the rest of the information there as well. And in the last equation, you have your x, but you don't have a y anywhere. So make sure that you write your y in that case, because your matrix that we actually put will look different if you forget one of those spots. So now we have the equations all written out. The first thing I'm going to do is put a big line down on the right-hand side of my matrix. The only thing I'm putting after that line is the numbers that these equations equal to. So really, this line is the equal sign when we're rewriting our matrix. So we have a 3, a 1, and a 0 for each one of the equations. And now this augmented matrix, as we continue here, we just have to write each one of the spots. Basically, our first column is going to be our x. Second column is going to be our y. Third column is going to be our z. So that means we have a 2, a 1, and a 0 if we're filling in that first equation. The next equation would have a 0, a 1, and a -1 with that second equation that was given to us. And last but not least, we have a 1, a 0, and a 2 if we're filling in this matrix. Now, an augmented matrix has a lot of similarities to the regular matrix that you were doing, but that line is going to be a really important piece of information. So here are the bullet points that you can fill in. Notice that each row represents one equation. The vertical line is really the same thing as the equal sign. The first column represents just the coefficients of x. Second column represents the coefficients of y. Third column represents the coefficients of z. Okay? Any variable that doesn't appear in the equation does have to still have a 0 in that spot. Right? And then last but not least, the coefficients of the variable on the left of the vertical line, the constants are on the right. So if you have no variables with a number, that has to be on the right side of that equal sign. So feel free, if you need to stop here, jot some of these down before you continue with the video, feel free to do so. In addition to working with these matrices, what we can do with these matrices, just like we can do with the equation, is to change the equation. We can add, subtract, multiply, divide different things with each one of these rows that we have. So notice how we're going to do something called row operations. And it says, remember that to solve a system of equations, we can interchange the order within the system. So think back to a 2 by 2. And if you use elimination, you would have to multiply sometimes one of the equations by a number. It's the exact same thing with matrices. Okay, so we can multiply an equation by a constant and add the equations together. So notice here, there are really three things that we can do, and the notation here is going to be kind of an important piece. The very first thing we can do is says interchange any two rows. So you'll notice here on the right-hand side underneath the symbols, there is an arrow that goes both ways. That arrow going both ways means that those two rows would switch. So they would switch places actually in your matrix. So if it was like row 1 and row 2, that means when you rewrote the matrix, the order of those would be completely switched. Whatever was the second row would be the first. Whatever was the first row would be the second. Okay. Number 2 up here says that we can multiply a row by any non-zero constant. So we can take any row and multiply it by a number, which means every single thing would be multiplied by that number in the row. Okay? So all numbers multiplied by your C in that case. Right? It's in just the first or the second, but it's all of the things in that particular row. And the most common rule, as you can see here, number 3, it says add a multiple of one row to another. So this is going to be the most tricky one, which we're definitely going to talk about here a little bit. But you'll notice that it's adding rows together to replace rows. So this is the row that actually changes. Okay? And how we change it is based on the left-hand side. So let's actually look at a couple examples here. All right, so if we're looking at this very first piece of information, it has an augmented matrix, and you can tell it's an augmented matrix because there is a line going down before the very last column, all right? And we notice right away, after the arrow, since it's only going one way, the arrow is only pointing to the right. That means row 1 is the only row that changes. So we can rewrite our augmented matrix, and we know that row 2 is not going to change at all. It's still the exact same as what it was to begin with, because row 1 is after the arrow. Row 1 is the actual row that is going to change. And how is it going to change? We're going to take the original row 1 and subtract it with the original row 2. So when we do that, that means row 1 has a 1 for this first spot. We need to do 1 minus 0. 1 minus 0 gets us to have a regular 1 in that first spot. Okay? The second column now, it's row 1, so we have a negative 2 minus 0. Negative 2 minus 0 ends up with a negative 2. So far, nothing has changed whatsoever. When we get to the next one, we're going to notice we have a 3 minus a 1 in that case. Now we actually have a 2 in this spot. Right? And we continue with this very last part, the one after the equal sign essentially is 1 minus 2. We end up with a negative 1. So we have now changed one of the rows by doing what it was told us on the left-hand side by this row 1 minus row 2. And notice how both of those we used what originally started. If we're looking at the very next one here, there are 3 rows now, but only 2 of the rows are being changed. So in this case, we have row 1 and row 2 that are being changed, which means row 3 in this case, 0, 0, 1, and 2 are not going to change whatsoever. That third row stays the same. So now let's change row 1. It says in order to change row 1, we're going to take the original row 1. So we're going to take row 1 added with 2 times row 3. So let's actually write some of these numbers out. So we have row 1, which is a 1, added with 2 times whatever row 3 was, which is 0. So what we get in that case is actually just a regular 1. we take the same thing out, row 1, which is a 0, add it with 2 times whatever row 3 is in that same column, and it's another 0. So we end up with a 0 in that spot as well. Now we get a little bit trickier because it says row 1, which we have is a -2, added with a 2 times row 3, which is a 1. So a -2 plus, actually it's a 2, we have another 0 in that case. And now the very last spot that we have, where we have a -3 added with a 2 times 2 in this case, or -3 plus 4, and we end up with a 1 in that spot. Okay, notice in this case how we have a 1 in the very start, a 0 with the rest of the way until the equal sign, and then we have a 1 at the very end. Okay? Let's see what this next one actually gives us. So if we give a 2 of our row 2 minus a 1, row 1, excuse me, that equals a row 2. So 2 of row 2. So if we have 2 of row 2, that's 0 minus our row 1. That means, and again, it's the original row 1, not the answer we just found. So that is a -1 in that case. Okay? The very next spot now, 2 of row 2. That means we have a 2 times 1 in this case, subtracted with the answer that we got originally from row 1, and that is 0. That means that we have a 2 in that spot. And the third spot that we have would be 2 of row 2, so it's 2 times 2 in that case. We minus row 1, which is a -2, which, look at that, causes all plus signs there. So 2 times 2 is 4, added with another 2 is 6 in that case. And now the last thing we have to do is after the equal sign, we have 2 of row 2, which is 3. We minus row 1, so we have another double negative case. So 2 times 3 is 6, added with another 3 is 9. And voila, we have all of these taken care of. Now here is a little insight into why matrices are so nice and they will eventually save you time. Because in this case, we know that if we were trying to solve this, let's just hypothetically say these are the x's, these are the y's, these are the z's, and those are the numbers. If we were to write this equation, we would just say that 1x is equal to 1. Or by doing this, we've just found out that x equals 1 in this equation. Okay? If we did the same thing for the last piece of information that we have in the last equation, we would say that 1z is equal to 2, or that z is equal to 2. We have just figured out 2 of the variables and then could, if we had to, very easily solve for the y. All right? This is what you're ultimately going to get to by the end of this video. All right? The last piece of information before we really do some examples, just to give you some background information, is something called row echelon form. Okay, your calculator is the reason we have to talk about what this is, because your calculator has a couple different options, okay, on how to put these in and how to use them to be able to solve and actually get answers. So row echelon form, it says any rows in a matrix consisting all of zeros are at the bottom of the matrix. That's one of the rules that we have. All right. The second rule says for each non-zero row, so for any row that has numbers, the leftmost non-zero entry is a 1, which is what we want. If we are looking at a matrix in this case, ideally for us, we want stuff like this, because then we know that in that case, x would be equal to 3. It would be really nice for us to work, okay, and figure out what the rest of the numbers are. That first rule, if you would like a picture form of that, would be all zeros, which means, oh, it could be a no solution, it could be an all solution. It's something that doesn't quite work, right? And then last but not least, rule number 3, it says for 2 successive rows that have numbers, the leading one in the higher row is farther to the left. So there's a particular order that we would like. We would love in every way, shape, or form if matrices always gave us something like this. Because then I'm just going to go here and use different numbers. In that first equation, you know that x would be equal to, in that case, 3. In the last equation, you know that z would be equal to 5. And then you could use those for the middle equation to solve for what the other letter in case y would be. So you always want a 1 and zeros underneath it at the far left. You always want a 1 in the middle with zeros above and below. Okay, that's going to be as nice and as easy for you to work with. Now, there is a little bit more. The best one, just like a fraction, you can have a fraction that might not be reduced in the lowest terms. This is what we're looking for, reduced row echelon form. It says every column containing a leading one has a 0 in every position. This is the button that you're going to want to use when possible in your calculator because it's going to give you the easiest option as you go through. And notice here that there's all ones and zeros on the left-hand side. That means in this example, x would be equal to 3, y would be equal to 4, and z would be equal to 5. Without doing any work, your calculator will have the power to give you that if something does work out. All right. So notice here that we're trying to figure out if this is in row echelon form or if it's in reduced row echelon form. So notice that very first matrix that you have has a 1 in the first row on the leftmost part, which is really good. All zeros after it, which is awesome. We could essentially find, in this case, that x is equal to 1. Awesome, really good. But there's one big rule that this is missing. This is not in row echelon form, okay? And if it's not in row echelon form, if it's not in ref, then it can't be in reduced row echelon form, or ref, as I like to call it, either because these two rows are essentially flipped. Okay, the 1 that's in the very bottom would actually have to be in the second equation in the middle for it to be in both reduced or regular echelon form as well. Okay, if you're looking at the next example that we have with this matrix, notice how the 1s kind of go all the way down. So in this case, the 1s are nice. There's zeros underneath them. Okay, there would be our nice dotted line or a line that says where our equal sign is. Okay, and there should be a big reason why we know that this is row echelon form. So that's good. This is ref, row echelon form, but it's not reduced row echelon form. The reason it's not reduced row echelon form is because of that 2 that we actually have. It's not quite simplified all the way. It's still simplified pretty nice, but just not quite all the way. And then last, but most certainly not least, the third example, kind of similar. Notice how you have your 1s that are on the diagonal, which look really nice. Okay, you have a full 0 row all at the bottom. Perfect. Okay, however, similar to the last one, you don't have all zeros around those 1s. So this is actually the exact same option. This is in this is in row echelon form, but not reduced row echelon form at all. Okay. So now, if you haven't done so already, you're going to have to grab your calculators because we are actually going to put some of this into action here, right? So if you want to, okay, the first part of your assignment is going to be the 1 through 39 odds. If you check your Google Doc, there is that information. You can see what the picture is. You can see the answer key in there, and you can stop here. Or if you want to keep going, you can obviously pick up to do the last part of it as well. Okay. So our goal now is to use this to actually find an x and a y and a z. These are calculators with matrices to solve and do the same work that you did before. All right. So here's the key. There's going to be some equations that you're going to solve that only have one answer. You know, an answer that looks something like what we wrote in the past, 3 variables, our x, our y, and our z. All right. And the key here is an example of this would be something that is already in reduced row echelon form, where we have 1s going over, we have zeros all around, and then with the numbers that I used before, your calculator would tell you something like this. So the key that you're looking for is that the diagonals are all 1s and that there's zeros everywhere else. And again, that describes reduced row echelon form. It's the most common answer that you get, right? More than likely, your calculator is going to give you something that looks very similar like this, all right? There is other alternatives that you have, and in that case, we could also have a no solution answer, right? And you're going to have something very similar. It could be any numbers that you wind up with that your calculator tells you, and it gives you something like that in the first line. And while it definitely does not in reduced or echelon form, it's something you can still work with if you absolutely needed to, right? If it gives you even a second row, that again is not ideal, you might be able to do something with yet, but the third row is going to be the key because you see all zeros in that case, and you have a number after that. So what that's telling you is that essentially you have 0 equals 1. That is a big red flag as to why you know that is a no solution. So if you ever have a row of zeros that equals a number, then no solution is going to be what your final answer would be. Okay? Now, as you go through, same kind of thought process with your infinitely many solutions. I'm sure that you know that and you can figure out what this is going to look like. But an example of an infinitely many solutions, again, might be something like that. You might have the second row, which looks really good, where you're going to have an all 0 row that is equal to actually 0. That means every single answer that you tried to put in would work for your variables that you're figuring out there. So you have your row of zeros that actually does equal 0 in this case. So when we go through and use our calculator here, you're going to get one of these 3 answers every single time as you're going through. Right? Now, let's actually try an example. All right? Here's the key. The first thing we have to do is write this in a matrix. So we need to double check and make sure that our x's, y's, or z's are all lined up, that everything is looking pretty good there. So it looks like for this example, we already have it. All right? Now, as we go through, we know that we are actually going to have 4 columns in this case, where our x's are going to be first. I'm going to put each of those x's down. My y's are going to be next. My z's are the following thing that I write in, and then my constants are all after my equal sign. All right? And now what I need to do is I need to put this into the calculator. So I'm going to grab my calculator here, and now you're going to have to kind of follow along. Notice I will have my keystrokes on the bottom here too, or else you can pause the video to see how we put that in. So notice how there is a matrix button in your calculator. If you notice your green alpha button, and you go 2 down from that, right, there's a little blue above the x to the negative first that says matrix. So you need to click the blue, and then you need to click the x to the negative first or your matrix. So in the very first spot, notice it's going to say A, B, C, D, all the matrix that you can possibly use, okay, which is fine. We're not going to use that yet because the next column has all the things we can do with these matrices, all right? It works out super nice. And then last but not least column is the edit column, and this is where you actually have to put a matrix into your calculator. So you can click A, B, whatever matrix you want. It does not matter. I'm just going to click on A, and notice how the first thing it's asking for what the order actually is. So the order that we have to figure out is, well, based on what we drew here. So notice how the rows that we have are 3 rows, and then we have 4 columns. So the order for this is a 3 by 4. So now we have to actually go in and put this into the calculator. So I have a 3 by, I'll scroll over, a 4. And when you do that, it should be the exact same as what you have on your screen. And if you don't get it to be the exact same, then mess around, maybe put the wrong order in. Okay? Notice here, though, this is not technically listed as an augmented matrix because there is not a line that goes down. That's okay. Your calculator will still calculate it as if it was an augmented matrix. Now we need to put the actual numbers in. So I need to put a 1 in that first spot here. I'm going to put a 2 in the next spot, a 1 in the next spot, a 3 in the next spot. And this is where you have to be really careful to make sure that the numbers that you're using are the same, and you're not forgetting to type something in, or you're typing it in wrong. Okay? Very simple mistakes that you can do in this case. So you're just typing each of the numbers in, and then you are going and pressing enter afterwards. Okay? So after you do that, this is the key. You don't need to save it. There's no button to save it. So what you can do though is hit the quit button. So hit the second button, and then right next to it is the quit, and it brings you back to your home screen. So now we need to do something with this. Okay? We're going to go back into the matrix. Okay? and go over to the middle column where it says the math part of it. Just like the math button can be really useful when we're working with fractions, this math button inside of the matrix spot is going to be really useful as well, because it has all of these things that you can do. And some of these we're going to figure out right now, eventually, and some of them you're going to learn a little later. But if you keep scrolling down, notice how eventually you get to ref, row echelon form. Looks kind of similar to some of the examples, obviously, that we just went through. But if you scroll one more down, this is the bread and butter right here, because it automatically has reduced row echelon form. So if you press enter to that, now the calculator is asking you, all right, hey, what do you want reduced row echelon form of? So we have to tell them which matrix we want. So then, with the cursor inside the parentheses, go to your settings, back to the matrix. And now notice how my A has something in it. It says a 3x4 matrix is actually there, right? That means there's data in that one. So if you press enter to this spot, now that A will show up actually inside of this. And if we end these parentheses, click enter, and it tells you what the reduced row echelon form is. And notice how you might be thinking, oh boy, if I actually look at this now and I know that that is essentially my equal sign here, this isn't in reduced row echelon form. It's because this data doesn't have a most reduced row echelon form, because there's one important thing. Notice that last row has all zeros to it. Okay? That's why reduced row echelon form actually couldn't be an answer for us, because it's not. Because if we go back to this, what my expectation would be now is I want to see what your calculator actually said. I want you to show me what your calculator actually gave you as an answer. And I know that the last spot gave me all zeros. And I actually have to type in now what the rest of them gave me, which was a 1, a 0, a 1.4, and a 3.4. It gave me a 0, a 1, a negative 0.2, and a negative 0.2 in that case. But we know that since this last column, or sorry, the last row, excuse me, is all zeros, we have an infinitely or an all solutions as our answer in this case. All right? So the nice part is your calculator is going to help you out. I have to see in your work, especially in your progress check, the matrix that you started with, the matrix your calculator gave you, and then whatever your final answer is. So essentially, I got to see a 1, I got to see a 2, and I got to see a 3 on each one of these problems. Right? The practice associated with this is not just kind of like a regular point and chart. You're going to be looking at word problems, trying to make the equations from them, and then using your calculator with reduced row echelon form. All right? Good luck.